All right, good morning, everybody. If it wasn't for these bright lights, I could compliment you on how good of an audience you are today, but you're quite hard to see. But how's everybody doing this morning? Are you alive? Let's hear some cheering. Yeah? All right. We've got to get everybody woke up this morning. All right. Well, just want to say thank you for joining us for day 2 of the 2025 North Dakota Transportation Conference. You know, transportation is very important in North Dakota. From my role in the North Dakota League of Cities, you know, I like city streets, but really all transportation is connected. So I want to say thank you to all of you for joining the conference and all that you do in your communities and counties, townships, wherever you're at. So I'm not going to spend a lot of time up here because we have an exciting session next. Just a reminder, put your phones away. Our speaker today, I was showing him how to shut off his phone in the back. I hope you do the same because we have a good session coming up. And also there will be a Q&A at the end. Now I'm sure this is a room full of engineers, but it's okay to talk. You don't have to totally formulate your thoughts before you ask the question, so have your questions ready, write them down, put them in your head. We'll have a Q&A towards the end if we have time. But without further delay, it's my pleasure to introduce our next speaker, which is Mike Herzog, the Director of Bridge Construction with BNSF. So let's give him a round of applause.
Hey, good morning, everybody. As Matt said, my name is Mike Herzog. I am the Director of Bridge Construction for the BNSF Railway, and it's a pleasure to come speak with you this morning about BNSF's journey to develop and start construction on our bridge replacement project over the Missouri River. Today, I'm going to hit on 4 areas during the course of this presentation. I'm going to talk to you about what our project is. We'll move into talking about what BNSF expected and considered during project development. And then the third area, we'll get into some of the construction plans and ongoing progress and what to expect in the coming years. And then lastly, we'll close it out with some thank yous, as there were many companies and agencies that played a role in helping us get to the point where we're at today. Okay. All right, let's start out with the slide on the screen right now is giving you an overview of the Bismarck-Mandan area. And the intent of this slide is to really show how this bridge connects our system. In the middle of the screen is the location of the BNSF bridge. And coming in from the east on the Bismarck side, you have our Jamestown subdivision on the Twin Cities. The Jamestown subdivision on the Twin Cities division. Traveling on across the bridge to the west through the Mandan Yard, you have the Dickinson subdivision. And then going off to the north on the west side of the river is the ZAP line that heads out to the Republic. Okay, let's talk a bit about our existing bridge. As far as what our project is, there are 3 areas that I'm going to hit on with regards to what our project is. And on the screen now, we have some pictures from the original construction and a follow-up project that took place. The picture in the upper right-hand corner is the finished product from George Morrison when they built the bridge in the early 1880s. And then on the lower part of the screen is the follow-up project that took place a few decades later where they had to replace the 3 truss spans. This project to replace the spans was driven by the dramatic increase in the weight of locomotives and rail equipment. And for me, it hits on the point of everything has a finite life. And for these spans, it was a short life. It was only a couple of decades. I could sit here and geek out about looking at these pictures. I find them so interesting, looking at the construction techniques they used to replace these spans and do this big work back in the day when machinery wasn't as plentiful. I think about the amount of false work they're using to support the spans for disassembly of the existing spans and that gantry system that they're using to assemble the new spans. And what I want to hit on with looking at these pictures is, first and foremost, BNSF's project is a condition-based replacement. Cornerstone of bridge ownership is bridge inspection. It's getting quality and timely bridge inspections, watching how that bridge ages, watching how it responds under load, And then from that information, using it to determine what repairs you need to make. And then over the course of time, for railroads, it's a matter of placing restrictions on there. And in the case of this bridge, we do have currently speed restrictions for trains traversing the bridge, in addition to weight restrictions that prevents certain short, heavy cars and certain product from traversing the bridge, in addition to the inherent dimensional load restrictions you get with any through truss span. Okay, BNSF's bridge over the Missouri River is just one out of our 13,400 bridges, and that equates to roughly 325 miles worth of bridges on the BNSF system. On the slide on the screen provides you a visual distribution of these 13,400 bridges and showing the age distribution in 20-year gaps. So looking at this distribution of ages, one could expect a person needs to commit quite a bit of effort to maintaining and replacing these bridges as the end of their useful life comes up. Annually, BNSF commits around $250 million to replacing bridges. This is broken up by roughly the type of bridges. With that, I mean we have $150 million that we use to replace smaller bridges where our own forces are predominantly doing the work. And then we have another program called the Heavy Bridge Program, which the Bismarck Bridge is part of, where we spend roughly $150 million a year to replace larger bridges that are too big for us to design, permit, and construct with our own forces. So we have a small pool of trusted consultant and contractor partners we use to rebuild these bridges. Any one time, that $100 million will have 3 to 5 of these bridges in construction around our system and another 10 to 15 in development. And the point I want to hit on with this slide, second part around what the BNSF project is that $100 million price tag to replace this bridge in Bismarck. It's 100% privately funded. No grants involved. It is just purely part of our capital replacement program. Last point I want to hit on talking about what the BNSF project is looking at the population of railway bridges over the Missouri River, from the headwaters in Montana down to the confluence of the Mississippi River in St. Louis. This bridge is one of 22 railway bridges that traverse the Missouri River. These bridges are owned by various Class 1s and short lines, and their age ranges from the 1880s to 2013. Okay, the next few slides here, I'm going to show some examples of other heavy bridge projects where there are these larger projects that are too big for us to do, and the larger bridges where communities have a connection to their bridge. This one is a Trinity River Bridge just north of downtown Fort Worth, Texas. You can see the truss in the foreground. In the background, you see a couple other trusses. What's hard to discern in this picture is those trusses in the background are on subsequent tracks belonging to other railroads, and they were affectionately known as the Three Sisters Bridges. And when we came to replace this bridge, there was some emotion around it. It was a piece of history in Fort Worth. Some similarities this project has with the Bismarck Bridge project is our ultimate design concept we chose for this project utilized something other than truss spans. We were able to optimize it for cost and schedule, and the replacement concept went in with through-plate girder spans. Picture on the screen now is showing construction in progress, and this bridge will be done yet this year. Next example of a heavy bridge project, a little bit larger scale, a little bit more ties to the Bismarck Bridge. This is in Burlington, Iowa, over the Mississippi River. This is another George Morrison bridge from the early 1890s. Excuse me. So this project was, all these projects, are condition-based replacements. And in this picture, you could see how the approach spans are being replaced with truss spans, and that was what made sense with regards to maintaining openings for marine traffic and the conversion of the swing span to a vertical lift span. Okay, shifting gears here a bit. Next topic, let's talk about what BNSF expect and consider when we were developing this project. Going into this project, BNSF had 3 criteria that we needed the replacement bridge to meet. First and foremost, we wanted piers for the main river spans that could accept a future second track. We have no plans for a second track. This is just a step we take because of recognizing the cost and effort and environmental impact associated with constructing these piers. And the thought process is we're willing to construct these piers essentially at our own risk, because if we ever do come back, this will be the most difficult part of the project, and that way it would already be constructed. The second criteria is minimizing those impacts on the environment and the public. And third criteria, having optimal cost, schedule, and efficiency. Now, going through the rest of this presentation, there will be a few examples, multiple examples of deliberate actions by BNSF to satisfy the minimization efforts talked about in second criteria there. All right, here's a map of the immediate area around the BNSF bridge. This slide shows features in the vicinity of the bridge that strongly influence the preferred concept. In the northeast quadrant, you have the high bluffs with the underground water reservoirs. Traversing across the bridge, you're roughly 90 foot above the water, to landing on the west side where you are in a very tall embankment, roughly 75 feet tall. And just a bit further to the west, you have the BNSF overpass going over the Bismarck Expressway. To the north, on the west side, you have the Missouri River Natural Area, and then to the south, you have our neighbors in the Captain's Landing Township. During project development, it quickly became evident that to satisfy criteria 2 with regards to minimizing those efforts on the environment and the public, and criteria 3 for optimal cost and schedule, the replacement bridge needed to thread that needle through these features by staying within the BNSF right-of-way corridor. Okay, this slide really gets at what we expect. This slide shows the 31 heavy bridge projects that have been completed over the last 10 years. $64 million question at the start of developing this project. How long is it going to take? How long is it going to take to have the design complete, permits in hand, land, easements acquired, any utility relocations, funding and contracts in place to start turning dirt so we could program this funding? This slide, as I said, shows all 31 projects from the last 10 years, and the duration represents the time frame from signing a contract for design to signing a contract for construction. And the current average looking at these 31 projects is right around 3 years. One item to note, these bars are sorted by duration, not chronologically, so there's not a recent trend on what it's taking to get through the permitting process. Interestingly enough, I can say the 3 most recent heavy bridge projects for BNSF that we are just now starting construction on were developed from that conceptual phase to signing that contract to construction in only 18 months. Okay, getting a little more specific on the project timeline for Bismarck. You see on the left-hand side, Q4 of 2014 is when we signed the contract with TKDA Engineering to start the development for the replacement concept. And it was in Q2 of 2023 when we actually had all permits in hand. For Bismarck, with the long timeline we were experiencing, we took the initiative to go outside of our normal operating procedure of have permits in hand, then bid it out to help reduce that exposure for contractor change orders. And we bid the project out ahead of having all of our permits. So the moment we had permits in hand, we could give the notice to proceed and get the contractor out there starting turning dirt. 2 milestones on this timeline that I'll go ahead and talk about because I didn't address it in the other parts of the conversation or other part of the presentation are on the far right of the screen. And those are the last 2 flags where we're talking about in-servicing our new bridge and our target for demobilizing and having the site restored. And that timeline looks at mid-2026 for lining track over to the new bridge, and then mid-2027 for having demo complete, site restored, and completely gone from the site. Okay, continuing on with would we consider, what we have up on this screen, on this slide, are the design concepts we considered. The alternative analysis for the EIS, 3 variables in the replacement concepts here. You have the span length, the offset to the north, and the alignment of the piers, as far as aligning the new piers with the old or offsetting them. One comment about going through this process, H&H analysis, evaluating the impacts from each one of these concepts to determine the stage increase. Our consultant, TKDA Engineering, followed the federally regulated process that involved closely working with FEMA for, I'd say, roughly around 12 months during project development to fully vet what this stage increase looked like. And the primary metric we were trying to meet was ultimately a no rise. Now, one question we sometimes get, or I've received since we've started construction, is about the 400-foot spans. Why didn't you look more closely at the 400-foot spans, maybe at less of an offset? And I'll say the 400-foot truss spans are more problematic in multiple areas. First, bringing in the track geometry from the east with the curves on the bridge, these longer spans made it more difficult and challenging for the track geometry to work. And I will say, from an ownership perspective, the 400-foot truss spans makes bridge inspection more challenging. It's a more extensive process and challenging to access all the locations to perform the bridge inspections. Lastly, when we're talking about 400-foot spans, the 400-foot spans require a much bigger footprint. So when we looked at the first criteria for what we wanted out of a replacement bridge, it conflicted between the first criteria and the second criteria because a future second track would have a bigger footprint, more impact on the environment. Okay, and the other question we often get as we looked at our concepts were all these concepts are offset to the north. Did you look at anything offset to the south? And we did this intentionally because any offset to the south would have encroached much more on our neighbors in the Captain's Landing Township. And while the permitting process for this project was emotional, I would really suspect that encroachment on property that people actually own would have made it that much more emotional. A couple more comments about the design concepts considered. The first 2, where we were looking at 92.5-foot upstream, those concepts are illustrated in the lower left-hand corner of the slide, where we're showing the piers of the new bridge aligned with the piers of the old bridge. Having piers aligned like this, having to go with that 92.5-foot offset, pushed us outside of our right-of-way or increased the cost dramatically to stay within our right-of-way. The other comment, looking at concepts 3 and 4, where it was offset much less, we were able to achieve a no-rise condition. However, that no-rise was only able to be achieved with the existing bridge being removed. So let's talk a bit about why no closer than 92.5 feet. That seems like a heck of an offset. And the reason for that really is the upstream side of those existing piers, the icebreaker. What you see above water is not the full extent of that pier. As you go down below water, it continues to extend further to the north. And when we were looking at 92.5 foot, that only gave us around a 10-foot buffer between the edge of the existing pier and the edge of the cofferdam that would be needed to construct the new piers. So even with this minimal 10-foot offset from the existing pier, that poses a risk to BNSF during construction to where we could potentially compromise our existing bridge before we're ready to put the new bridge in service. Okay, talking a little bit more about the 92.5 foot offset. This is an illustration of what things would have looked like on the west side, pushing things out. That 92.5 foot, the far right line is our existing right-of-way. So we're pushing the embankment out, and construction costs to build an offset alternative with the piers aligned, widen that footprint for the replacement bridge, and push us off our right-of-way, or needing to construct retaining walls to keep us within our right-of-way. These concepts for the 92.5 foot offset required significant premium costs for the retaining walls, added embankment, design permitting, in addition to moving that far to the north, put the track geometry where we could not get back onto our existing alignment before reaching the overpass for the Bismarck Expressway. So we would also have incurred having to build a new bridge over the expressway. Okay, this is showing a plan view of BNSF's preferred design, what I would call an efficient design. So this plan view shows how tightly we were able to pull in the replacement bridge into the existing bridge with the ultimate goal of staying within our right-of-way. It also optimizes civil work on both sides of the river. Okay, this exhibit here provides a better visual on what was the limiting factor around that 20-foot offset to the north. On the right side, you see the new 200-foot deck plate girder span adjacent to the existing pier. And what limited that 20-foot offset is the south girder line of the new bridge and the proximity to the existing piers. So that left us with a small buffer to give us a higher level of comfort during the demo operations. So this is a configuration that we'll have once we line traffic over to the new bridge and before we start demo operations. Okay, here is a rendering of the completed product. And to me, it's a good-looking bridge. And I get it, beauty is in the eye of the beholder. I see a bridge that, should future train traffic drive the need for a second track, the most difficult substructures have already been constructed. Second, while you really can't see it in this picture, the steel spans over the river include appliances that enhance the safety of bridge inspections. It includes ladders to get from deck level down to cap level, walkways between the girder lines, in addition to handholds / anchor points that run through the stiffeners for our inspectors to leapfrog around the stiffeners as they walk these girder lines so they can maintain 100% tie-off during their bridge inspections. And lastly, I see a bridge that has minimized the impacts to the environment and community during the construction. Okay, the other thing you'll notice in this rendering, it provides a good view of the widened piers. We just widened the piers over the river, and that was intentional. That was to minimize that impact on the environment and also capture that cost now because they will never get cheaper nor easier to build. What you may not immediately see in this rendering is the efforts that were employed on the land piers. During the design, the land piers, they do take into account the potential need for a future second pier. The batter of the pile, the shape of the piers, the shape of the stems have accounted for that second track should it ever come to be. And to clarify on the topic of a potential second track, we have no immediate plans for needing a second track. That is something that will be driven by train traffic, and should that day ever come where we need to build a second track, BNSF will have to go through the same federal permitting process to address the impacts associated with that project long before any construction starts. Okay, a difficult aspect of this project was construction. This is the west side showing the expressway and the Memorial Bridge. And to me, this is a significant example of reducing the impact on the public. The west side of the river had the greatest need for material delivery, starting with a couple 100,000 yards of fill to construct the new west embankment. And at this time, I'd like to give a big thank you to the North Dakota DOT for working with the BNSF through the need to minimize construction traffic on the Mandan residential streets. Okay, another effort BNSF has employed to communicate with the public on the status of the project, what's going on, what to expect, because we understand there will be impacts. Seldom does construction happen and not impact somebody. BNSF is maintaining the BNSF bismarckbridge.com. A lesson we've learned from practically every project is more communication. Just when you think you've communicated enough with everybody, try to communicate some more, whatever means possible. Always look for that next step to improve, to ensure the public is getting good information about what's going on and what to expect. Because in the absence of good information, I would say people tend to make up their own story and may not be completely accurate. Okay, what we have on the screen now is an exhibit from the report on the original construction of the bridge. And we'll get into now talking about some construction progress and an update of where we're at. This slide shows the cutting-edge technology for the 1880s. I could go through that book all day long, geeking out about the means and methods, how they used a series of airlocks and pumps and workers inside those caissons to excavate and sink those piers into place. Looking at our means and methods, how we are constructing our river piers, this exhibit shows the cofferdam system that Ames and TKDA jointly worked to develop. Plan view here shows the geometry of the piling at cutoff elevation and really does not give you that full picture of the wider footprint with the batter in the piling. We knew early on the river piers were going to be some of the more challenging aspects of construction of the new bridge. The new piers are comprised of multiple components founded on H-piling, going roughly 60 feet down below the excavation, utilizing a 10-foot thick seal course layer to act as a barrier to counteract the inward hydrostatic pressure and ultimately provide us a dry working surface for constructing our reinforced section of the pier. Work in 2024 focused on Pier 7, which is the first wet pier on the west side, and kudos to our contractor, Ames Construction. In 2024, we just took on one river pier, and they learned a lot, they worked hard, and it'll help set us up for working here in 2025 on Piers 5 and 6. Okay, measure twice, cut once. What you're seeing in this drawing is an exhibit that shows more of all the unique matter for each line of piling. And I'll say this really wasn't driven by a design need. This is really driven by what it takes to fit all 72 piling in each footing and be able to miss the existing bridge above you. You see on the right the batter for each pile. Left part of the screen, you can see the exhibit showing a 4-foot buffer between the pile leads and the existing bridge. Okay, continuing on, we'll get in some photographs showing work that's taken place. This picture shows progress from 2023 on the west bank. You see the west dock wall and the cofferdams for Piers 8 and 9. This dock wall helps facilitate marine access for construction of the river piers and makes construction of Piers 8 and 9 essentially a land-based construction instead of having to utilize part of the marine fleet for a water-based construction. One acknowledgement of what you're seeing here on the screen, we do recognize that the cofferdams, the dock wall does take a slice out of the open riverway. And I'll tell you, the consultant engineer, TKDA, worked with the Army Corps of Engineers on iterations of the H&H modeling that included these temporary works to moderate and minimize temporary stage increases associated with our temporary works during construction. One piece to minimize this stage increase you don't see are the culverts that actually run through the dock wall to help improve the flow during construction. Okay, mid-2024 progress. What I'd like you to notice in this picture is the multiple aspects of work taking place all at the same time. You have construction on the west embankment, many trucks coming in from the expressway. You have land-based work for the substructures on both sides of the river, and you have Pier 7 work taking place in the river, in addition to work Piers 8 and 9 on the west side. And all this work is taking place while we're still running trains as normal. I will say the railroad is a very unforgiving environment, and it demands the highest level of dedication to BNSF safety culture. BNSF has high safety expectations for our trusted contractor partners. Some examples of these expectations include just basic communication in the form of briefings, rebriefings, debriefings, to identify the work, identify the risks, and identify the efforts to mitigate these risks. This is an everyday occurrence taking place multiple times a day. Compliance with BNSF's PPE matrix that lays out what PPE is required for each type of work, and the empowerment of all employees to basically call a stop to the work when they have concerns or questions. Okay, this picture gives you a good view of Pier 7 towards the left-hand side. Pier 7 was the primary focus for 2024, which kept construction activities on the west side of the river. This picture shows intentional efforts to maintain that corridor for river traffic. Going into 2025, going into 2025, work will shift to the east side of the river on Piers 5 and 6. Mooring piling will be added along the edges of the river to help reduce cross trips across the river for marine resources. Okay, running short on time here. Pier 7, this picture is showing some of the pile driving taking place in 2024. Items to note in there, the contractors utilizing jigs and survey equipment to get the pile installed per plan. I'd point out, notice the close proximity of the pile leads to the existing bridge, and that's like threading a needle, and where that unique batter comes into place to be able to fit all 72 pile into each pier. Okay, this is the next step in construction of Pier 7. Left side shows all the pile driven, cut off at rough elevation. Seal course is poured, and we're in the process of dewatering. Picture on the right shows in the dewatered state, pile cutoff is made. You'll notice there's some of the piling that were left at a higher elevation. This was a design modification worked through by TKDA and Ames. It was a win-win solution. This allowed for better support of the reinforcing steel for the subsequent reinforced concrete on top of the seal course. And it's a good example of how our trusted partners work together, expectation that they work together to get the quality end product. Okay, next slide shows Ames placing the concrete for the pier footing and the cofferdam. At face value, not too impressive until you consider what it takes to get the concrete to the point of placement. This slide shows the extensive concrete conveyance from the ready-mix trucks through multiple pump trucks, some on land, some on barges, playing a game of concrete leapfrog to simply get the concrete into the forms. Okay, plan for 2025. As I mentioned, our efforts will be focused more towards the east side of the river, constructing the 2 river piers, 5 and 6, in addition to constructing the land-based pier at 4, which is adjacent to River Road. And with the increased amount of work on the east side of the river and the limited workspace between the road and the riverbank, we needed to close River Trail to eliminate this possibility of commingling pedestrians and construction traffic. Okay, getting into the closing piece here. Just a thank you. Logos on this slide just represent a lot of the players that played a significant role with communication, talking through the project, helping us through the permitting, working on the technical aspects. Too many people and groups to list out individually, but a big thank you to all that played a role in getting us to this point. You know, a few examples of partnerships include the construction access, the fill material coming from the Bismarck side for the West Embankment, and then the many agencies involved in the permitting and groups. All right, closing it out. I look at this as somewhat of a passing of the baton. Looking at the history behind this bridge, I get it. It's a really cool bridge. I geek out looking through the pictures and seeing how this was built, looking at the people that actually did the work. The picture in the lower right-hand corner is one of the few pictures showing the people inside the caisson doing the excavating, sinking that pier into place, and wondering what life was like for them. And this is history in process. We're doing the same thing, different means and methods. This is Pier 7 under construction, and this is one of those same workers. This is Troy, Ames pile driving foreman. He plays a big role in making this work take place. And I'll close out with another rendering of the new bridge, a bridge that'll be there for another 130 years. And with that, we got through right on time. I don't know if we want to do any questions.
Thank you, Mike. We probably have just a few minutes for questions. So who has a question for our presenter today? Well, while you think of that, I mean, comment I want to make is, yeah, you're building history today. You look at those old drawings, it's imagine 100 years from now what they'll think of our drawings. You know, as invested in this project as you are, what do you hope the people of Bismarck and, you know, North Dakota think of this bridge project when it's all done?
Well, it was a journey to get to this point, and what the real project really gets at is BNSF's commitment to maintaining our infrastructure, maintaining our bridges so they are safe, reliable, and available, and minimizing any exposure to our neighbors.
And this is something you do all the time. How many bridge projects do you have in progress as we speak?
So projects in progress for the heavy bridge program, we have 5 under construction right now, and probably another 15 in some stage of development, whether it's concept, active design, or permitting.
Wow, that's amazing. All right.
I have a quick question. I was curious, is there going to be any public interpretation of the old bridge in association with this project?
So during the federal permitting, we went through the Section 106 process, and BNSF, well, the outcome of Section 106, mitigation was identified as a grant program that BNSF funded at a level of $500,000 and being administered by the North Dakota SHPO, where they solicited grant applications to capture the history of the bridge. And that $500,000 will be used to fund those applications that were selected by the SHPO. Did that answer your question?
All right, great. Well, let's give Mike a round of applause.